Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Right now, as you're sitting there, you are moving at over 1,600 kilometers per hour. You don't feel it, you don't hear it, but you are spinning through space on a rotating planet. Our world has been spinning for over 4.5 billion years, a constant silent engine driving the rhythm of life. But what if, in an instant, it just stopped? What would happen to our oceans? Our atmosphere? What would happen to us? Tonight, we are going to explore the real science behind one of the most extreme what-if scenarios imaginable. First, why does Earth spin at all? It all goes back to its birth. About 4.5 billion years ago, a massive cloud of gas and dust began to collapse under its own gravity. As this cloud shrank, it started to spin faster and faster, a bit like a figure skater pulling in their arms to accelerate. That ancient momentum has never left us. Today, Earth completes one full rotation every 24 hours, giving us the fundamental cycles of our world, day and night, our time zones, and the very pulse of life itself. At the equator, the surface of our planet is racing along at about 1,670 kilometers per hour. That's faster than the speed of sound. The reason we don't feel this incredible speed is because everything around us, the air, the oceans, the ground beneath our feet, is moving right along with us. It's all one seamless system. But what if that system was violently disrupted? Let's imagine the impossible. The Earth instantly stops rotating. The solid ground would halt, but the atmosphere would not. The oceans would not. Everything not physically anchored to the planet's bedrock would continue its eastward journey at over 1,600 kilometers per hour. The immediate consequences would be catastrophic. This would generate global supersonic winds, a scouring force that would obliterate everything on the surface. Buildings, trees, and all human infrastructure would be instantly swept away, torn apart by winds far more powerful than any hurricane. Simultaneously, the immense inertia of the oceans would create tsunamis of unimaginable scale. These colossal waves would surge across the continents, washing over everything in their path. It's a scenario of total surface destruction. Now, it's crucial to understand this is a purely theoretical exercise. There is no known natural force or mechanism that could bring our planet's rotation to such an abrupt and sudden halt. But by continuing this thought experiment, we can learn a lot about the delicate balance of our world. So let's say the initial chaos subsides. What would our planet look like? One of the most dramatic changes would be to our geography. Earth's rotation creates a centrifugal force that causes the planet to bulge slightly at the equator. Our oceans are held in this bulge. If the spinning stopped, that force would disappear. The water would no longer be held at the equator and would be free to redistribute itself according to gravity. It would flow away from the equator and towards the poles. This would create a single gargantuan supercontinent wrapped around the planet's midsection, a belt of newly exposed land where the oceans used to be. Meanwhile, the polar regions would be submerged under incredibly deep new oceans. Entire coastlines would be redrawn. Cities like London and New York would be deep underwater, while new landmasses would rise from the sea. The map of the world would become completely unrecognizable. Next, let's consider the climate. If Earth stopped rotating but continued its yearly orbit around the sun, our concept of day and night would be gone. Instead, one side of the planet would face the sun for 6 straight months, while the other side would be plunged into a 6-month-long night. The side facing the sun would experience extreme, continuous heating. Temperatures could soar high enough to boil water in many places, creating a scorched, desolate desert. On the dark side, the opposite would happen. Without sunlight for half a year, temperatures would plummet to deep freeze levels, creating a world of ice and darkness. The most habitable parts of this new Earth might be in a narrow band between these two extremes, a permanent twilight zone or terminator line that slowly creeps around the planet over the course of the year. In this zone, the sun would always be near the horizon, creating a state of perpetual dawn or dusk. But even here, life would be a struggle. The colossal temperature difference between the hot and cold sides would generate weather systems unlike anything we know. Powerful, relentless winds would constantly blow from the hot side to the cold side, creating permanent planet-spanning storms along the twilight zone. Our familiar weather patterns would be completely gone. Earth's rotation is what creates the Coriolis effect, which gives our storms their spin and organizes winds into predictable patterns like the trade winds and jet streams. Without rotation, these systems would collapse. The climate would reorganize itself into a much simpler but far more brutal global pattern. Air would rise from the superheated day side, travel to the frigid night side, sink, and then flow back along the surface. Simple but devastatingly powerful. So could life survive? Not as we know it. The vast majority of plants and animals are adapted to a 24-hour cycle of light and dark. A 6-month day and a 6-month night would shatter these biological clocks. Photosynthesis would be impossible on the dark side, and the extreme heat on the light side would be just as deadly. Life would have to retreat. Perhaps some organisms could survive deep in the oceans, shielded from the temperature extremes. Or maybe hardy microbes could cling to existence in that narrow, stormy twilight zone. But human civilization would almost certainly perish. Interestingly, one thing that wouldn't change dramatically is gravity. You'd actually weigh a tiny bit more. At the equator, the Earth's spin creates a slight outward force that counteracts gravity just a little. If the spin stopped, that force would vanish and you'd feel the full, uninterrupted pull of gravity. The difference would be less than 1%, but it would be measurable. In reality, Earth's rotation is slowing down, but on a geological timescale that's almost impossible to comprehend. The gravitational pull from our moon creates tidal friction, which acts as a very gentle brake on our planet. This process is slowing Earth's rotation by about 1.7 milliseconds every century. At that rate, it would take billions of years for the Earth to become tidally locked with the Sun, where one side permanently faces it. And long before that could ever happen, our Sun will have expanded into a red giant, likely engulfing the Earth anyway. So, a sudden stop is firmly in the realm of science fiction, not scientific prediction. What this thought experiment really shows us is something profound about our home. It reveals just how essential our planet's quiet, constant spin is to the delicate balance that makes life possible. The simple rotation gives us the day and night that governs ecosystems. It drives the wind patterns that distribute heat around the globe and the ocean currents that stabilize our climate. Sometimes the most extraordinary thing isn't imagining a disaster. It's appreciating how perfectly tuned our world already is. The Earth will not suddenly stop spinning. But thinking about it reveals the incredible, intricate dance of forces that makes our planet a living world. We live on a planet in motion, a world spinning through the cosmos at incredible speed. And that motion, silently and ceaselessly, is what allows us to be here. If you enjoyed this deep dive into planetary science, make sure to subscribe for more cosmic, what-if explorations grounded in real physics. There are so many fascinating possibilities in our universe, and we're just beginning to understand them. Thanks for watching.